Okay. So, day 2, significant test for means. So, we have our Greek symbol, funky U, which is technically like talking about mu. And remember, that's our true mean. Alright. There is a typo here. This should have been sample mean, not sample proportion. So please change cross out proportion and make it mean. So these are just the steps. Okay, this first page is just reviewing the steps. We already talked about this yesterday. This is what we're doing. Step 1. So in step 1, we're going to identify what the true mean is. So just like we did last time, true proportion of the blah, 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 true mean of the whatever it is. It just comes right from the paragraph. We're going to identify our sample mean, x bar. What is the sample size? And what is our level significance, alpha? Remember, if we're not stated as level significance, it is always 0.05, if not stated. So if they don't tell us it's 10%, we're going to go with 0.05. If they tell us something different, we use it. But we go with 0.05 as the standard. We're going to write our ho and ha. Okay? As we talked about yesterday, the funky u, mu, is going to be equal to a number. And then mu will be either less than, greater than, or not equal. Those are our 3 options. Right? Just like the previous units. We're going to check conditions in step 3 like we've been doing. Does it tell us it's random? Usually it will. Normal. Does it tell us it's normal? If it doesn't tell us it's normal, n has to be greater than or equal to 30. There's our formula. Step 4 is just do the math, like previously. So we're going to take x bar minus mu divided by standard deviation over the square root of n. Very simple. Then we're going to find the area. Now remember, talked about this yesterday. Might want to have it somewhere in your notes. So we're going to hit the second button. We're going to hit the bars button. We're going to choose number 6, which is TCDF. And then we're going to enter our lower, our upper, and our degrees of freedom. Now, just as a subtle hint, lower, upper, degrees of freedom. This is TCDF. That's the choice you're picking on the calculator. TCDF. Just as a hint, if our number is negative, and we're doing a left tail, okay, we are going to have negative 999 as our lower, our negative t value, whatever that is, okay, and then our degrees of freedom. If we have a right tail, which means it's positive, okay, this is negative. We have a right tail. Remember, we put our positive t value in, then 999, and then our degrees of freedom. And then last step, we compare it to alpha, and we're either going to reject the ho or fail to reject the ho. Null hypothesis. And we're going to write out that statement again that we've been doing kind of all semester. All right, example 1. We're just going to go step by step here. Suppose battery companies come out with new batteries and say they're going to be way better than the regular one, but they're more expensive. So you want to justify, make sure they work. Current batteries are approximately normally distributed. That's a very important thing to find when you're reading. Okay? Which means we're not going to have to check large counts or greater than 30. It says last 30 hours of continuous use on average. On average, 30 on average, which means that's going to be our mu. A random sample, very important, of 15, so that's going to be our n, lasts an average of 33.9, so that's going to be our X bar, with a standard deviation of 9.8. These are the things you need to pull out of the paragraph. And then does this data provide convincing evidence, that goes in that last statement we used, that the batteries last longer? So that's going to be greater than. We're going to be using that in our ha. So, define mu. Okay, also don't forget, please scratch that out. That was a typo. It's supposed to be mean. So, what is mu? It is the true mean of what? What are we talking about here? Just battery life. Doesn't have to be that complicated. If you want to put in hours, you can put that. Whatever. But true mean battery life is fine enough. That's good enough. What else do we need? We need our X bars listed right there. So our X bar, we already identified as 33.9. We need to identify our N. Well, how many were there? It says there's 15. All right. And then our alpha, which is not stated, so that's going to be 0.05 because it was not given to us. Our null and our alternative, so ho, ha, funky u, mu, equals, and mu, whoopsie, that didn't go right. Mu, we said it's going to be greater than, we know that, okay, from that says last longer. What's the number we're comparing to? The 30 hours that they say they last. But we're hoping it's going to be longer. Remember, those numbers are always the same. Okay? When you're doing your ho and your ha, the number is the same. You don't change that. Check conditions. It told us it was random. Okay? And it told us it was normal. So we can just write given for both those. Bam. We got it. Now we do the math. So we take our average, 33.9, subtract our mu, 30. Now we're going to divide by the standard deviation, which was 9.8, divided by the square root of n, which was 15. So we take our handy dandy calculator. Okay, there we go. Make sure it's turned on. Come back here. Come on. Stay here. Be a good calculator. Wait, I just want you to go back. There we go. Okay, nice. So remember, we're going to do alpha y equals, choose a fraction. I put 33.9 minus 30 on top. Nope. Minus 30. Come on. This is not that hard. Minus. You're right there. Minus. I hate this. Oh, there we go. 30. That was a little too challenging. Okay, on the bottom, 9.8 divided by the square root . Nope. Why? Why can't you just, there we go, delete. Second. Oh my God, this board is not working today. Seriously? Down. right. So we get 1.54. Okay, so it's a positive one. So when we do this, 0, 1, 2, 3, where's 1.54? Right about there. We always shade the tail. Okay. Now, we're going to find the p-value. So we're going to use our calculator again. Let's say good luck with this one. All right, so we hit second bars. You should be doing this on your calculator practices to get the muscle memory. Second bars, which is over here by clear. You pick number 6, TCDF. Now, since we're going to the right, we're going to put our t-value right there of 1.54. And then we're going to put upper value of 999. The degrees of freedom on this bad boy is 14. 15 minus 1. Then we just hit enter a couple times. Notice that's the layout I just wrote in the notes. There's your lower, your upper, and your degrees of freedom in parentheses. And there it is. 0.0729. We always go out to 4 for the area. So it's 0.0729. About 7%, 7.3%. So now everybody's favorite part, we're going to write our sentence. So we're comparing the 0.0729 to the 0.05. Okay? 0.0729 is greater than 0.05. So, since my p-value, which was 0.0729, is greater than alpha, 0.05, we fail to reject, because remember, it was greater than, so we're going to fail to reject. We fail to reject the hoe. Or you put no hypothesis, whatever. Okay? Fail to reject the hoe. We do not have convincing evidence. We didn't do this part yesterday, but this is going back to the old way. We don't have convincing evidence. Evidence. The true mean for battery life is greater than 30 hours. More practice, the same thing. Now notice this one's not laid out step by step, but the steps are in the box. So first time you have a skeleton fill out, now we are going to step by step. Same thing though. Number 1, we identify our mu. So let's look at it. So many entertainment options. Doctors are worried teenagers are not getting enough exercise. So some of the teachers chose number of sit-ups in 1 minute as a measure of fitness. Suppose that in 2000, the average number of sit-ups for some freshmen could do in 1 minute was 36. To see if it decreased, high school teachers took a random sample of 35 freshmen and found the average to be 28 with a standard deviation of 12. Does this data confirm the concern? So, what's my mu? My mu is the true mean number of sit-ups freshmen can do in 1 minute. Okay? So our mu is what we're looking into is the true mean, the true average number of sit-ups freshmen can do in a minute. Okay? My x bar, let's find out where that was. What is the average number? It says to found the average number to be 28. My n, the number of, that's an m, not an n. My n is the number of students that were chosen. random sample of 35. Random is important, so it's number 35. And then my alpha, which was not stated, we always go with 0.05 in that condition. That's number one. We've done it. We've identified mu, x bar. Oh, got standard deviation. My bad. Standard deviation is right here. Standard deviation of 12. Okay? That's everything. Number two, we do our ho and ha. Very simple. Ho, ha. So mu, both here, equals a number. We're looking for the number that they found they could do, and it was 36. They think it said it was going to be less than 36. They predicted under that. It said to see if this value decreased. Decreases, doesn't go down. So we're checking for decrease. That's it for 2. Step 3, check for random. Random, question mark. It was given. It said random. We're good to go there. Normal. Did it say in there that it was approximately normal? No, it did not. But we have 35 students, which is greater than or equal to 30, so we're good to go. So if it doesn't tell us it's approximately normal or normally distributed, we compare the numbers, and we're good to go. Number 4, we're going to do our math. T equals, our T number is x bar, 28, minus mu, 36, divided by standard deviation, which is also divided by the square root of our number. And we'll just write down here that our degrees of freedom makes it 34. Now, the thing about this is, since we're using the calculator, we do not need to go down to 30 because we're not using the chart. We're going to stick with the actual degrees of freedom. On to number 5. Draw our beautiful distribution. Okay, we're at negative 3.94. 0, negative 1, negative 2, negative 3. Where's 3.94? Way out there. So teeny tiny. You kind of already know it's going to be less than alpha because it's teeny tiny on the outskirts. But we're going to do the math. So we're going to do our TCDF. And I painfully am going to bring up the calculator again. Okay, so we go to second bars. You should be doing this on your calculator to practice this. Second bars, number 6. Now, remember, we're going left now. We're doing left tail. So we put negative 999 here. Our upper is our negative 3.94. Our negative t value. Our degrees of freedom we said were 34, and now we just hit enter, enter, enter. We hit enter quite a few times, just until we get our number. Yeah, we did. I put 34. Now, look at what it gives me. It gives me 1.922. But it says to the negative 4. 1, 2, 3, 4. So remember, on the calculator, whenever you see that E negative 4, that's scientific notation. That's the same thing as 1.92 times 10 to the negative 4. Okay? That looks like this. 1.92 times 10 to the negative 4. That's just the calculator way of showing scientific notation. So we're going to move that decimal 4 places to the right. Okay? We want 4 numbers, right? Well, here's our 4 numbers. We're going to round. So our number is going to be 0.0002. We said before it was going to be teeny tiny. It is teeny tiny. It's almost 0. It's practically 0. And then our last step is to compare that to 0.05. Obviously, that's smaller than 0.05. So we do our sentence. Number 6. Whoa. Since my p-value, I'll put in parentheses, 0.0002 is way less than 0.05, oh sorry, alpha. Alpha, 0.05. Okay? We reject the hope. Or the null hypothesis. Okay? We don't have convincing evidence.
What do you mean?
Convincing evidence that the true mean number of freshmen, number of sit-ups freshmen can do in a minute, almost said an hour, that'd be easy. So in a minute is less than 36. I knew something didn't seem right. I meant to say do. We do have convincing evidence. I wrote it down wrong. So we do have convincing evidence that it's less than 36.